Hi, name's Rohan Ray. Now, I know some of you might be asking about the VSPER model of how when you get the tetrahedral shape, why is it 109.5 degree the bond angle? So I did a mathematical derivation of that, and this is how it went like. So first I draw the example of a tetrahedral model in the VSPER model, and it's called methane. It's CH4. So this is how it looks like in 3D. This is 0.110, 111, 010, and then the C is the center of the tetrahedral shape, which I put half. Now this H is also 001. So what I did is put examples of coordinates over there, and then since C is in the center, C would have half of those one coordinate, so it'd just be half. So then I drew in a two-dimensional diagram to see how it looks like in a two-dimensional diagram. And I just located the points in the three-dimensional paragraph into the two-dimensional diagram because I understand that the three-dimensional one is a little bit confusing. Like the points, I guess it's kind of recognizable, but you know. So first let's define what bond angle is. Bond angle is practically the angle between the center of the atom and one of its bond lengths. So like for example, one of its elements which is also part of the bond length. It's kind of hard to like describe it, since I'm bad at defining stuff. But suppose we have the particle atom CH4, right? So the bond angle of that one is the angle between the H and the C. And then the angle and the bond between the H and the C, and the bond between the H and the C, and the angle it's forming. So, where's my mark? Oh, there it is. Oh, so it's practically this angle right here. That's the bond angle. So I'm gonna call that theta. So theta is supposed to be 109.5 degrees. So let's find out let's find out theta. Okay. So first we need to find out the vector of one of the H's and the C. So I calculate the vector. One of the coordinates is 001 and the C coordinate is half. So when you do that, the vector unit for the CH is half I hat plus half J hat minus half K hat. So that's one of that vectors. And then we're going to find out another vector, another H and another C. So what we found out was this vector in 3 dimension, and now we're going to find out this vector in 3 dimension, right? So we know that this is 1, 0, 0, and this is half. So when we do this, we get the vector of negative half I hat plus ij plus half j hat plus half k hat, and all we did was that we only did the subtraction of the x component and just wrote I hat plus the difference between the y coordinate, well h minus c, and then times j hat plus the difference of the z coordinate, and then times k hat, right? So that is what I did over there. But sorry, no, I did C minus H, not H minus C. So that's the two vectors that we found. So we found that the two vectors are negative half I hat plus half j hat plus half k hat, and the other one is half I hat plus half j hat minus half k hat. So now all we need to do. So these are the two vectors that we found in 3 dimensions. Now all we need to do is, I did a cross product of those two vectors. So this is the cross product formula, and this is what I did. Now, sorry, the focus is very bad. So these are the two cross products that I did, right? The two cross products. So in order to find out a cross product, all you just do is make a matrix. So you first list out the I, J, and K, and then afterwards you list the coefficient of the first one. So the first vector was the vector that I chose. I chose the first vector to be negative half I plus half j hat plus half k hat. So I wrote down the coefficient of this for that one, and then afterwards I wrote down the coefficients of the next vector, which is half, negative half. So when you evaluate it, we want to find out what the cross product is practically the orthogonal vectors of the two vectors that we have. So if you have like an x vector and a y vector, the orthogonal of that one would be the z vector. Now what we did is that since we were finding out the orthogonal vector, we first need to very bad focus. Alright, so we first need to find out the I vector. So the I vector is located right there, right? So we cross out all this and all that, and we find the determinant of this one, this one, this one, this one. And how to find out the determinant? You just do this one times this one minus this one times this one. And then minus, because since we have a j over here, j is in the position 2 and 1, so the addition is an odd number, so that's why it's a negative sign. So then afterwards, we cross out this one, and then we find out the multiplication of these ones minus the multiplication of these two for the determinant, and then that's minus, and then plus k hat. I hate this one. Plus k hat, and then this is k hat, right? So we cross out this one, and we just multiply this one times this one, and then minus this one times this one. So you should get an orthogonal vector of negative half I hat plus negative half k hat, right? So that's the orthogonal vector. And now we need to find out the magnitude of the orthogonal. Now see, since these are the only two coefficients, and there's also a j coefficient, but that's 0. So all you just do is negative half squared plus negative half squared plus 0 squared. Now 0 squared is just 0. And you just do square root of that. So your magnitude of the cross of this one should be 1 divided by square root of 2. Now let's find out the magnitude of the this vector over there. Now see, the magnitude of this one is that since it has all the components, it's just negative half squared plus half squared plus half squared and the square root of that. And you should get an answer of square root of 3 over 2. Now for this one, it's just square root of half squared plus square root of half squared plus negative half squared, and square root of that, which is also square root of 3 over 2. Now these are the magnitudes of these two vectors. Now we can apply this formula right here. So now when we apply this one, we found out the answer of this one is 1 over square root of 2. The answer of this one is square root of 3 over 2 and square root of 3 over 2. So since we need to find out theta, sine of theta is equal to 4 square root of 3 over 2. So theta is equal to sine inverse of that, and you should get an answer of 109.471 degrees. Now that rounds off to 109.5 degrees. Thank you very much for watching this video. I'm probably not going to make more videos of this because I'm too busy doing other stuff. So yeah, that's my video. I hope you like it. Bye.